This is Kansas, the 34th state of the U.S. Nowadays, it's mostly flat farmland, primarily used for cattle and wheat, so it may be hard to believe, but the state was once covered entirely by water. During the time when dinosaurs ruled the earth, North America was cut in half by an ocean known as the Western Interior Sea. Much like the oceans of today, the Western Interior Sea was filled with all sorts of strange sea life, from colonies of bizarre invertebrates to a variety of otherworldly fish. And in the Western Interior Seaway, everything ate everything. While dinosaurs ruled the land, and pterosaurs ruled the skies, the oceans were similarly ruled by another group of great reptiles, the marine reptiles. Today, most marine reptiles are semi-aquatic, like crocodiles and marine iguanas, and only a few that are fully adapted to life in the sea, like the sea turtles. But during prehistory, the marine reptiles were a diverse and strange group. From the shark-like ichthyosaurs to the streamlined plesiosaurs, all highly capable hunters, but even in a sea full of giant predators, one of them has to be at the top of the food chain. The mosasaurs were a diverse group of marine reptiles, most closely related to monitor lizards and snakes. But unlike their cousins on land, mosasaurs featured 4 paddle-shaped flippers to help them swim through the sea. The first mosasaur fossil was discovered in the Netherlands during the 1780s, many years before the first dinosaur fossils were even discovered. At the time, scientists weren't entirely sure what it was. Some believed it was a fish, while others proposed it was a crocodile. Eventually, it was agreed to be a relative of monitor lizards, and was given the name Mosasaurus. A number of other mosasaur fossils were discovered around the world, but the first mosasaur found in Kansas was during the Bone Wars, a time during the late 1800s when 2 paleontologists, Edward Cope and O.C. Marsh, fought to name the most prehistoric animals across North America. While Cope was the first to describe the new mosasaur from Kansas, naming it Macrosaurus, the name was eventually changed to Tylosaurus, meaning knob lizard, named after its nose which extends past the teeth. Since then, Kansas has become a hotspot for marine animal fossils, most notably mosasaurs.
So mosasaurs are a group of aquatic marine reptiles. We call them varanid reptiles, which includes things like monitor lizards and Komodo dragons that are alive today. But these animals were prominent in the late Cretaceous. So there are different ranges and sizes of mosasaurs. There are some smaller ones like the Cleidastes to the larger ones in our area, which are like the Tylosaurus. So they could get anywhere from 10 feet long to about 40 feet long. So they're pretty dynamic animals. They're some of the most common marine reptile fossils that we get in western Kansas.
Of course, like all life, they don't start out as giants. During the late 1800s, it was thought that mosasaurs may have crawled onto shore in order to lay eggs, like sea turtles do. However, with the specialized body shape and size of mosasaurs, this likely would have been impossible. It's far more likely that mosasaurs gave birth to live young. Fossils of other marine reptiles like ichthyosaurs in the middle of live birth have been found numerous times. Mosasaurs were likely no different. In 2020, a soft-shelled egg thought to belong to a mosasaur was described. However, most scientists believe that it is unlikely to belong to a mosasaur.
If it was found on land, mosasaurs did not come out of the water. As far as we can tell, there is no evidence that they ever came out of the water onto land to lay eggs. But structurally, for mosasaurs to come up on land, especially the larger ones, like a Tylosaurus or even the Platycarpus, like the one behind me, is that if they came up on land, they would end up beached like a modern day whale or a modern day porpoise or something that comes up on land. And what ends up happening is they die of asphyxiation. Basically, they would crush themselves under their own weight. because this is where their lungs are, and they wouldn't be able to breathe. So they would run into some of those problems that we see modern marine animals have when they get beached on land.
It was also once believed that mosasaurs gave birth in shallow water, where their young would spend the first few years of their life. While this may be the case for some species of mosasaurs, fossils of juvenile mosasaurs have been found in areas where the sea would have been very deep and open.
Things like behavior, and especially any sort of reproductive or parental behavior, are always so difficult to figure out in the fossil record. A lot of people like to hypothesize that maybe they moved into shallower areas and give birth where the young could be more protected, but those are questions that we really don't know the answers to. We had so much mosasaur diversity, so many different types of mosasaurs filling different parts of ecosystems at this time, that most people think that they were kind of compartmentalizing these marine ecosystems. So you would have had some mosasaurs that were near shore, and some that were offshore, and some that ate deep into the water, and some that ate in shallow water. So, there's going to be a pretty healthy debate over what species was doing what, or what species was going where to have their young. And that's just, we don't have a good enough fossil record to really kind of make generalizations for the whole group, or really even the individual species.
It's hard to figure out how mosasaurs took care of their young from just fossils, but in the open ocean, they would have likely needed protection. The western interior seaway was teeming with predators. Some even call it Hell's Aquarium.
So one of my favorite descriptions I've ever heard of this western interior seaway is Hell's Aquarium, because we have all of these big, fascinating fossils, these huge animals with big teeth filling this ecosystem. So you kind of imagine it's not really a place that you want to go swimming. So in addition to the mosasaurs, there are lots of other predators, kind of other animals competing for the top of the food chain. We still had big sharks, kind of like we do today, and would have been kind of related to distantly and similar ecologies to what we see with great whites and tigers and things like that.
The most fearsome of the Kansas sharks was Cretoxyrhina, also known as the Ginsu shark. These sharks would have reached sizes of up to 26 feet in length, larger than today's great whites. Cretoxyrhina bite marks and embedded teeth are commonly found on many fossils pulled out of the Kansas chalk, even mosasaur fossils.
We also had really big bony fish, so Xiphactinus, which is our very famous fish within the fish, the big fish of the fish within a fish, got to be 12 or 15 feet long with these big pointed teeth. So we still had big fish like we do today, and we also had other types of big marine reptiles, plesiosaurs specifically, so kind of like the one behind me, of again these big-headed or big-bodied, long-necked fish-eating, reptile-eating, turtle-eating predators with these big conical teeth, also filling a lot of these predation roles within the ecosystems. These are animals that would have competed against mosasaurs as adults, but also would have preyed on mosasaurs when they were smaller as juveniles and babies.
But for mosasaurs of any size, the most dangerous predator they could ever encounter was another mosasaur.
We do have some evidence of what appears to be smaller mosasaur or younger mosasaur bones that have actually been digested or partially digested and spit back out. So we do know that there was some mosasaur on mosasaur predation. We also have evidence of biting. We actually have a specimen in one of our main galleries of a Tylosaurus that has his head crushed by another larger mosasaur. And while we can't say for sure that is predation, it is definitely behavior. So we know that for whatever reason, face biting was a kind of mosasaur behavior, which would allude to the fact that they were probably territorial, but we don't know what the exact scenario is. Is it a younger mosasaur getting too ambitious and getting into another's territory and nope? Or was it, a young male mosasaur trying to cozy up to a larger female, and that was a reaction to that? Or was it actually predation? So all we can say is this gives us a little bit of a snapshot into mosasaur behavior and how they kind of interacted with one another.
Most species of mosasaurs weren't picky. For the largest mosasaur, Tylosaurus, everything in the interior sea was on the menu. Sharks, fish, ammonites, plesiosaurs and plesiosaurs, turtles, aquatic birds, and of course other mosasaurs. Smaller species like Platycarpus and Cladastes, while not as large as Tylosaurus, still likely ate a variety of prey.
We have things like Clydastes, which has these more slender teeth on them, so maybe eating smaller fish versus big predators. We have Actinosaurus, which has more of kind of this like gharial crocodilian type of snout. So probably eating something a little different there. And then my favorite is Globidens. And Globidens is this really cool mosasaur with these little teeth that are rounded on top and shaped like mushroom. And these were shell eaters. So they were crushing shells, clam shells, crab, lobster shells, ammonite shells with these rounded hard teeth. So filling actually a very different role of predator in an ecosystem than a lot of these mosasaurs with their big conical teeth. So doing a lot of different things in these very dynamic ecosystems.
In the ocean, just about every animal is a predator, so speed is key, both to eat and to keep from being eaten. One of the most defining characteristics of the mosasaurs are their long tails. By swaying their tail from side to side, they can propel themselves through the water, using their flippers to steer.
Mosasaurs, the closest analogy I have for what a mosasaur would have looked like in the water as it was moving around from place to place would be something like a modern day water monitor, like a Merton's water monitor. The mosasaurs would have had a slightly shorter arm and leg span. Their obviously limbs are more adapted to be in the water, but they are not using their limbs to power their way through the water. They're primarily tail swimmers. So as these animals were moving through the water, they would sort of tuck their arms and legs up against their body and swim through the water in a very serpentine-like manner.
There's been much debate recently regarding the shape of mosasaur tails. In the past, it has been accepted that their tails were likely paddle-shaped, but when a prognathodon fossil from Jordan was found with the soft tissue impression of a tail fluke, it changed everything.
So yeah, there's a little bit of a debate as to what the mosasaur tail looks like. So one side sort of supports the idea that mosasaur tails looked a lot like modern water monitor tails that have a keel down the back and that are well suited for sort of swimming through the water. The other side of the argument is that mosasaur tails might have been fluked sort of like a whale's tail, where you have that sort of back fin shape, based on some fossils that have been found where the bones sort of go downward, and there's sort of an assumed cartilaginous structure that makes that the rest of that fluke. So that's still kind of a hot debate. We'll just have to wait until we get more definitive evidence from the fossil record. But there are pretty good arguments on both sides to support each argument. So that's one of those kind of exciting things that's happening in mosasaur paleontology right now.
While the western interior sea was filled with mosasaurs, these giant reptiles refused to be confined to a single ocean. Many species of mosasaurs can be found all over the world.
Mosasaurs absolutely have this global distribution. We find them in a lot of these inland seas, like we have here in Kansas. We find them in Europe. We find them in Australia, where we have good inland sea deposits. And in coastal areas, again, worldwide, we have them from the Antarctic Peninsula all the way up to a few fragments in the Canadian high Arctic. So we know that they were very wide-ranging in terms of pole to pole in the equator and everywhere in between, and filling a lot of different roles as predators in these ecosystems.
While mosasaurs may have rapidly spread across the ocean, they went extinct even quicker. With the disappearance of the dinosaurs, so too did the giant marine reptiles vanish off the face of the earth.
Geologically youngest mosasaur specimen that I know of was found off the coast of New Jersey. And it's suggested that it hung on, or that mosasaurs hung on for a short time after that impact event. But like everything at the time, ecosystems were collapsing, and there was just not enough of a food to support large bodied reptiles like mosasaurs. So eventually they went extinct.
Today, we know their existence from their remains cast in stone and locked in time. While the mosasaurs may be gone, their relatives, the monitor lizards and snakes, still live on. And while the mosasaurs were among the first prehistoric animals to be discovered, there are still many mysteries about these incredible leviathans.
There's a bunch going on in mosasaurs. They're kind of really big right now in terms of paleontological research. There's a pretty healthy debate going back and forth in terms of mosasaur origins. Are they more closely related to monitor lizards? Are they more closely related to snakes? Other things that people are looking at, kind of looking at the diversity. People are always describing new species, trying to figure out who's more closely related to whom and where they came from when. Some of the research that we're doing here at the Fort Hayes and Sternberg is actually looking at how these animals were growing, so taking their bones and cutting them up and looking at the preservation of growth, so we can answer questions about whether they were warm-blooded, whether they were cold-blooded, how fast they may have grown, what that means for metabolism, and what that means for kind of these predator-prey relationships within the ecosystems.
Mosasaurs actually have gained traction in popular culture, in part thanks to the Jurassic World movies. So as a mosasaur researcher, I was pretty excited to see a mosasaur being represented in something that many people are viewing, and then in turn seeing them come into our museum and not only be excited to see them, but be able to identify which kind of mosasaur we're looking at. So that was very exciting for me in terms of what that means for the legacy of mosasaur research.